Nice. Chapter 1. Particle Theory of Matter. Now, particle theory is an awesome thing you really need to know. It's the basic of physics, the basics of chemistry, and however, it's not the basics of biology, so if you're going to be a biologist, you're still going to need to know this if you want to know all about that respiration stuff. It's not the basics, so that's our cells for. But right now, for chemistry and physics, this is basically the basics. Now, the particle theory of matter basically talks about how does three states of matter work out and how what the elements are and the compounds are and particle theory of matter are. I've explained this all in another video, but I just going to explain it all again. There's this rule called conservation of mass. Mass cannot be destroyed, nor can it be created. In fact, you can't do neither. The mass will always stay the same. If you put in an input, the output will have the same mass as the input. The output will be the same mass as the input. If you have two inputs, then the output will be the same mass as both of those inputs combined together. There's no way you can destroy mass. There's no way you can destroy energy. There's no way you can create mass nor energy. Of course, then we found out there are ways you can create mass, although we still have no idea how to make energy. This is still going to be a weird episode. And there's also this thing where methane is always four parts hydrogen and 1 part carbon. These ratios are always there, and it's not because of some weird fundamental rule, it's because of how the atoms are arranged. I mean, think about it, you put in the input, and the output is basically the same thing as the input, except it's just an input rearranged in a different way. That's basically what this is. And hotter the things is basically what makes it bouncier, and probably also the reason why balloons fly. And what if ice sank? Now, ice should sink in solid terms, because all solids are less dense than water, so it should fall down. It should sink. However, ice apparently is more dense. How? It's ice. Well, there's an exception to the solid will always sink because unless it's less dense than water rule. I should have said more dense earlier, but right now it's less dense than water rule. It's ice. Ice can float because of the way it's structured. H2O looks like Mickey Mouse, to be honest. So that's how it seems to look like. And when you turn it into ice, it turns into these little hexagonic structures, which make sure. And since water is basically the same thing as those Mickey Mouse ears, and the ice is made of the same Mickey Mouse ears, they interact together so that, well, they float. And however, because of heat stuff, ice keeps sinking. And this is what happens to every seals every year now. So every time and now. And seals suddenly get an ice bath. And it's also kind of an insult to Titanic for iceberg to literally go flat on top of it. Also, it hasn't happened yet, which is nice. So, in short, the smell or taste of everything is just the particular way of the arrangement of particles, even cow farts, which are mainly methane. There's also something you might like to know, but you don't need to know, but you would like to know. You know that solids, liquids, and gases are basically all the three states of matter. There's, of course, one more state of matter that is supposedly told here. It's called plasma. In my school, now most schools usually don't teach about plasma because you're not going to encounter much in your life unless you're going to be one of those special scientists. Also, my school is all like plasma's the fourth state of matter, and there are no more states of matter. However, it's basically just ionized versions of gas, which means it's basically hotter version of gas. There's also, and you can also make it in your microwave, but don't blame me if you make it in a microwave and you cease to have a microwave. And there's also a fifth state of matter. It's called the supercooled bosons, but you can't make it in the microwave, so I'm gonna go away from this, and that's about it. So right now, see you soon. Shout out. Peace!